Hello pre-calc students, doing a walkthrough of the series homework. So for problem 1, I'm going to start it with problem 1, very thoroughly done out for you. We know that the first term, a1, is negative 6. And first we need to see if this is an arithmetic or a geometric series. We need to do a test. We need to see if there's a common difference or a common ratio. And that's what we're doing right here. We can see that there's a common difference. We have a common difference of 5 because negative 1 minus negative 6, that's 5, and 4 minus negative 1 is also 5. So because term 2 minus term 1 and term 3 minus term 2 are both 5, we know this is an arithmetic series. So we see this is an arithmetic series. And the explicit form for an arithmetic series, so this is an explicit form, is going to be an is dn plus a1 minus d. So an is equal to 5n minus 11 because d is 5, right? And then a1 is negative 6 minus 5, which is negative 11. So 5n plus negative 11 is just going to become an is equal to 5n minus 11. So now we're, remember, writing each term in summation notation. So now that we have the explicit form, so we found the explicit form, we're putting the explicit form right here. We know we start at the first term, so n is equal to 1. And then we just need to figure out what a final term is in the term. So here it's going to be 13. The final term is 13, and the reason why is because if we can find the explicit term an is equal to 5n minus 11, we can set up the equation 54 is equal to 5n minus 11. Add 11 to 54, you're going to get 55. 5n minus 55 equals 0. 5n is equal to 55. Sorry, my bad. 65, sorry. 5n is equal to 65. 65 divided by 5 should be 13. And so because of that, we have n is equal to 1 all the way up to 13. All right, so let's do problem number 2. 1 plus 4 plus 9 ... plus n plus 1 squared. So in this case, let's just start with sigma notation. We're going to start with the first term. N is equal to 1. And this is always going to be up to, so this is the first term. This is the second term. And this goes all the way up to the n plus 1 term. Because note, the first term is 1 squared. The second term is 2 squared. The third term is 9 squared. And you just get this by pattern recognition. The fourth term, it continues all the way up to n plus 1 squared. So this goes all the way up to n plus 1. So our stopping number is, I was just doing that to show you guys. Our stopping number is n plus 1. Our stopping number is n plus 1, and because of that, 1, 4, 9. So this is going to be each term squared. 1 squared is 1, 4 squared is 4, 3 squared is 9. The pattern is going to be the term number squared, so of n squared. So that is the term in series notation. For the third term, it looks like we have a geometric series. I can just tell right off the bat that we're multiplying by -2 every single time. So this is geometric, and we're multiplying by -2 every single time. So, looking at our geometric series, to express this in sigma notation, we could say that, remember, the first term is going to be A1 times AN is equal to A1 times R to the n minus 1. So we could say this is going to be from AN, we write the explicit form, so this is the explicit form. AN is equal to, and this is all from your formula sheet, A1 times R to the n minus 1. So A1 is -6. Except for, in this case, we're doing our common ratio an infinite amount of times. So AN is going to be equal to A1 is -6 times R, our common ratio, which is going to be -2 to the n minus 1. So writing in sigma notation, our starting value could be 1, n equals 1. Notice that this series continues adding on forever to infinity. So our stopping value is infinity. And then we just have -6 times -2 to the n minus 1. So that is our infinite series. Another possible way to do this is to divide 6 by -2 and have our stopping value be 0. So another right answer could be for this one, for this problem. You don't have to do it, but let's say you got sigma notation n equals 0 to infinity of 3 times -2 to the n. So what we did, -6 divided by 2 is 3, and then instead of having n minus 1, we have it to the n, but now instead of our starting number being at 1, our starting number is at 0. All right, let's go to 4. 2 plus 5 plus 10 plus 17 plus ... 65. So here, we're going to have to notice a very similar pattern to problem number 2 for problem number 4. Notice the first term is 1 more than the first term in problem number 2, plus 1. 9 plus 1 is 10. Excuse me. We keep on going up to 65. So hopefully you can see here the pattern is that each term is equal to the term number squared plus 1. All right? And so to find our, and because it stops at 65, we need to find our stopping number. So for the last term, if 65 is equal to n squared plus 1, then 64 is equal to n squared and that means 64, take the square root of each side, and 8 is equal to n. So our last term in this series is going to be term number 8. Term 1, term 2, term 3, term 4, 65 is term 8. So because of that, we can do a series. We start at the first term at 2. Then we have the 8th term at 65. And our explicit rule, vast majority of the time, you just have the explicit rule for the product of your series notation is going to be explicit rule. That's going to be n squared plus 1. Just wanted to state that that was the explicit rule. Anyways, clearing annotations. That's 1 through 4. All right, let's keep going. Problems 5 through 8. Find the sum of the arithmetic sequence. So we have 5, 9, 13, all the way up to 53. So notice we add 4 each time. So this is arithmetic. So you're going to have to start being able to recognize these patterns. All right. So an is equal to 4n plus 1. And that's because the first term is 1 times 4 plus 1. To be more specific, this is for any arithmetic term, that's going to be dn plus a1 minus d. So think about it. dn, d is 4n, plus a1, 5, minus d, 4. 5 minus 4 is 1. So an is 4n plus 1. Now we need to find what term 53 is. So 53 equals 4n plus 1. Then 52 is equal to 4n. 52 divided by 4. That's 13. So 53 is the 13th term. So that's term number 13. So now we need to find the sum of the series. So the sum of an arithmetic series, Sn, or at least because this is 13, the sum of a series with 13 terms, S13, is equal to 13 over 2, because it's n over 2 times a1 plus an. So a1 is 5 and a13 is 53. So when I do this, I'll get S13 is going to be equal to, remember that's n over 2 plus a1 plus an. So if you're the 13th term, it's 13 over 2 plus the first term plus the 13th term. So that's going to be 5 plus 53. So that'll be, we can do 13 divided by 2, 6.5. 5 plus 53 is 58, so multiply that by 58. And you're going to get 377. And that is your answer for S13. Clearing annotations. No, I'll go back. All right, so that's number 5. For number 6, we have 2, 5, 8, and 41. So we have 2, 5, 8, and 41. So let's look at the pattern here. Add 3, add 3. So we're adding 3. So AN is equal to DN. So that's going to be 3N and then 2 plus A1 minus D. A1 is 2. D is 3. Because remember, add 3 each time. So this is arithmetic, not geometric, because we're adding each time. And we see that by recognizing the pattern. A1 minus D, that's going to be 2 minus 2, 3, AN plus, in parentheses, A1 minus D. So 2 minus 3 is negative 1. So 3N plus negative 1 is just going to be 3N minus 1. Notice this will check out the first term. 1 times 3 is 3, minus 1 is 2. Second term, 3 times 2 is 6, minus 1 is 5. Third term, 3 times 3 is 9, minus 1 is 8. So now we need to find what term 41 is. If 41 equals 3n minus 1, add 1, we'll have 42 equals 3n. So 42 divided by 3. That will be 14. So n here will be equal to 14. So n equals 14 here. So because n equals 14, we can do S14 is equal to 14 over 2 times A1, which is 2, plus AN, which is going to be 41, because our 14th term is 41, and that's all we're adding up to. So we have our series, S14 is going to be equal to 2 plus 41 is, so 41 plus 2 will do it all, equal to 43 times 14 over 2, that's going to be 7. So times 7 will be 301, and that's our answer. So S14 is 301. 7. 111, 108, 105, 21. So for 7, it looks like we're subtracting 3 this time. So we subtract 3 each time. So subtracting 3, so AN is equal to DN plus A1 minus D. So AN is equal to negative 3n plus A1 minus D. So that's 111 minus negative 3, so that's going to be 114. And let's check that out. For the first term, you have negative 3 times 1, which is going to be negative 3, plus 114, 111. For the second term, n equals 2. Negative 3 times 2, that's going to be negative 6, plus 114. Well, that's going to be 108. So this is the correct explicit explanation. So now we have to find what term 21 is. If 21 is equal to negative 3n plus 114, then we'll have to, for 21, subtract 114, and then divide by negative 3. So that means our value is 31. So n is equal to 31. All right. So S31 is going to be equal to 31 over 2 plus times 111 plus 21. So that's going to be 31 divided by 2 is 15.5 times 111 plus 21, so that's 121, 131 times 132, that's 2046. So that's equal to 2046. All right. For 8, you'll have 7, 12, 17, all the way up to 2 plus 5n. And here we are adding 4 for each term. So an, remember adding 4, an is equal to dn, which is going to be 4n. Plus a1 minus d a1 minus d, so that's going to be 7 minus 4, so 4n plus 3. So check this out. First term, 1 times 4 is 4, plus 3 is 7. Second term, 2 times 4 is 8, plus a plus a1. Oh, that's plus 5. My bad. So that should be, sorry, 7 plus 5 is 12. Plus 5 is 17. So it's going to be an is equal to dn 5n plus a1 minus c. So that's 7 minus 5, so 5n plus 2. So the first term is going to be 5 times 1 is 5, plus 2 is 7. Second term, 5 times 2 is 10, plus 2 is 12. Third term, 5 times 3 is 15, plus 2 is 17, so it looks like we're fitting the pattern with our explicit rule. Now, Sn, this goes all the way up to 2 plus 5n. So Sn is equal to n over 2 times A1, which is 7, plus AN, and our final term here, it's in the abstract term, so it's going to be plus 2 plus 5N So in this case, all we can really do is simplify the algebraic term, which is going to be n over 2 times 7 plus 2 is 9. It's going to be 9 plus 5n. Clear annotations? All right. So those are the answers to the first 8 problems. Now we are going to do the next page, which is on pages 9 through 16. For problem 9, find the sum of the first 9 terms for the sequence 4, 12, 36, 108. So S9 is going to be equal to 4 times 1 minus 3 to the 9th over 1 minus 3. This is going to be equal to remember, this is the sum of when n equals 1, all raised to the 9th power, times 4, because our first term is 4. Our common ratio, we multiply by 3 each time. 3, all to the n minus 1 power. And this is let's break this down. This is because here our A1 term is 4, at least for problem 9, and our R is equal to 3, because this is a geometric sequence, all right, and you have to multiply by 3. So S9 is going to be, remember, F for the formula for any geometric sequence. So let's write it out to begin. Is that Sn is equal to A1 times 1 minus r to the n over 1 minus r. So A1 times 1 minus r to the n all over 1 minus r. And so here, because we're asking for the first 9 terms of the sequence, that's why I have a 9 as the coefficient, or sorry, for the exponent for our r term, because we're multiplying by 3. So with that being said, this is the answer to S9. So we just need to take our calculator and do some calculating. 1 minus 3 to the 9th is going to be negative 19,682. Multiply that by 4. That will give us negative 78,728. Divide that by 1 minus 3. So divide that by 1 minus 3 is negative 2. Divide that by negative 2. And we should get our answer of 39,364, which is the correct answer. So that's going to be equal to, remember, 39,364. So you should get this value with your calculator. Okay. Find the sum of the first 8 terms for the sequence 3/2, -3, 6, -12. So we already know it's geometric, so we don't have to test to see whether it's arithmetic or geometric. And we can see that our common ratio here is we're going to multiply each term by -2, because multiplying 3/2 by -2 becomes -3. -3 times -2, so we're multiplying each term by -2, because 3/2 times -2 is -3. -3 times -2 is +6. +6 times -2 is -12. So our r is equal to -2. Remember, Sn is equal to a1 times 1 minus r to the n over n minus r minus 1. So just know that there's 8 terms. So because it's 8 terms, S8 is going to be equal to a1, which is going to be 3/2, times 1 minus r and here r is 3/2. One minus r is r is 2, so 3/2 is a1. Our r, remember, our r is -2, so Freudian slip on my end. Minus the -2 to the 8th, and actually that won't matter, but regardless, over 1 minus -2. And so in this case, we plug this into our calculator. And so for the first 8 terms, we would have 1 minus -2 to the 8th. So -2 to the 8th power. Sorry. So let me be very clear here. -2 to the 8th power is 256. So 1 minus 2 to the 8th would be 1 minus 256. So that's going to be -255. Multiply that by 3/2. You get -382.5. And then you divide that by 1 minus -2, which is going to be divide that by 1 plus 2, so divide that by 3, and you will get -127.5. So you get -127.5. Find the sum of the first 10 terms of the sequence 5, 10, 20, 40. So each time we multiplied by 2. So hopefully we were getting, let's just go straight into the pattern here. S10, first 10 terms is going to be A1, 5 times 1 minus R here is 2, multiplying 1 minus 2r to the n to the 10th power all over 1 minus r. So 1 minus 2 So plug this into a calculator, we will have 1 minus 2 to the 10th negative 1023 times 5, all divided by 1 minus 2, which is going to be divided by negative 1. So we have, in this problem, 5,115. So S10 here is equal to 5,115. Problem number 12. Find the sum of the first 6 terms for the sequence 18, 9, 9 halves, 9 fourths. And so let's do S6. S6 is going to be equal to 18 times 1 minus 1 half to the 6th power over 1 minus 1 half. So S6 is equal to 18 times 1 minus 1 half to the 6th power over 1 minus 1 half. So that's going to be equal to 567 over 16. And this is because our first term is 18, and then we multiply by 1 half each time. And so minus 1 half to the 6th power. So that's 1 half to the 6th power all over 1 minus 1 half. So that should be equal to 567 over 16. To be more accurate, though, we can say we have 1 minus 1 half raised to the 6th power. That's 0.98. Multiply that by 18. You get 17.7. Divide that by 2. That gave you 8.85. 8.85. Let's do math. Frac. 5. So that actually be 567 over 64. So I guess there's a typo in the answer key. And what I can also do is double check the math here. So so let's check this out. We have, as long as we have 1 half to the 6th power, so 0.5 to the 6th. All right, 1 minus 0.015625. Right? Multiply that by 18. Divide that by 0.5. And you get okay, 567 over 16. So I put it into the calculator wrong the first time. So that's 567 over 16, which is equal to 35.4375. So that's problem number 12. Clearing annotations. for problems 13 through 16, the sequence is either arithmetic or geometric. Find the formula for the nth term of each sequence. Find the nth term. Find the sum of the first n terms of the sequence. So for 13, you have -2, 1, 4, 7, all the way up to 15. So let's figure out whether it's arithmetic or geometric. Are we adding or subtracting? -2. So 1 minus -2 is 3. 4 minus 1 is 3. 7 minus 4 is 3. So this is arithmetic. So for A, this is arithmetic. So 13 is arithmetic. And D equals 3. So for part 1, we need to find the formula for the nth term of each sequence. So basically for part A, when you find the explicit term, you need to know that AN is equal to DN times A1 minus D. So AN is equal to 3N DN, because D is 3, 3N, because 3 is D, plus A1 minus D, plus -2 minus 3. So that's going to be -5. All right, so that's A, 13. AN is equal to 3N minus 5. Okay, so part B is find the nth term. So when n is equals to 15, A sub 15 is equal to 3 times 15 minus 5. So 3 times 15 is 45, minus 5 is 40. That's equal to 40. And part C, find the sum of the first n terms of the sequence. So for C, we need to find S15. So that's S15, and that's going to be equal to n over 2, so 15 over 2, times A1, which is -2, plus AN, which is A15. So A15 is 40. So that's going to be -2 plus 40. So in our calculator, we can do 15 divided by 2 times -2 plus 40. So that's going to be times 38. That's going to be 285. So S15 is going to be equal to 285. All right. That's 13. 14. Hopefully you can see this is geometric. You're multiplying by -1/2 each time. 4 times -1/2, -2. -2 times -1/2, +1/2. Oh, yeah. And this is just a typo here. I know this is a typo because you're not adding, and this should be a +1. Then after that, a -1/2. After that, a +1/4, and so on and so forth. So here, our AN is equal to 4 times -1/2 to the n minus 1. And that's because just their explicit form for a geometric sequence, because this is geometric, is going to be A1, AN equals a1 times r to the n minus 1 power. R to the n minus 1. So an is equal to 4 times negative 1/2 to the n minus 1 power. So therefore, A14 is going to be equal to 4 times negative 1/2 to the 14 minus 1 power. So this is definitely a calculator term. We can just take our calculator, take negative 1/2 raised to the 14 minus 1, that's going to be the 13th power. And then multiply that by 4. And this will give you that value. Let's see if we can turn this into a fraction. So this, yeah, negative 4.88 times e to the 4th. Let's just put it this way. This would be the same thing as 1 over 2 to the 11th. So this would be 1 over 2048, or negative 1 over 2048, my bad. So this would be equivalent to negative 1 over 2048. Because if you really think about it, this would be 4 is 2 squared times negative 2 to the 1 over negative 2 to the 13th. So that's 1 over 2 to the 11th. So negative 1 over 2048. That's A14. To find S14, that's going to be equal to A1, 4 times 1 minus negative 1/2 raised to the 14th power all over 1 minus negative 1/2. So that's going to be a big calculator term, but we can do it if we can do it piece by piece. So we have negative, we have 1 minus negative 1/2 raised to the 14th power multiply that by 4. Divide this by 3/2. And this should give us math frac. This will give us a value of 2.666, or in a perfect fraction, 5461 over 2048. So this will give us, I think it's prettier in fraction form, 5461 divided by 2048. So this looks complicated, but once you get the formula, it's just knowing what to plug in. So that's 14. Let's do 15. 7, 21, 63, 189, n is equal to 9. So for 15, we have an a. Okay. So for problem A, an is equal to 7 times 3 to the n minus 1 power. B, a9 is, and the reason why I do 3 is because I'm multiplying each term by 3. For B, a9 is going to be 45,927. And I get that by doing 7 times 3 to the 8th power. Because that's 9 minus 1. So 7 times 3 to the 9 minus 1 becomes 7 times 3 to the 8th, which is 45927. For problems, so that's B. And for C, S9, it's going to be A1, which is 7, times 1 minus R, multiplied by 3, minus 3 to the 9th power, all over 1 minus 3. And so my calculator, I'll have 1 minus 3 to the 9th power times 7 divided by 1 minus 3. So you divide that by 1 minus 3, so that's going to be 1 minus 3 is negative 2. So our value would be 68887. So S9 would be equal to 68,887. That's 15. Let's do 16 now. Problem 16 would be negative 1, comma, negative 1/3, comma, 1/3, comma, 1. Well, n is equal to 16. So this is a pretty could say this seems complicated, but hopefully you can see that you are adding 2/3 each term. So this is arithmetic because you add 2/3 each time, so D is equal to 2/3. So this is arithmetic. So AN is equal to DN, so 2/3 n plus A1 minus D plus negative 1 minus 2/3, or plus negative 3/3, negative 1 is 3/3, minus 2/3 is negative 5/3. So that's negative 2/3 n minus 5/3. A16 is going to be equal to 2/3. So 2/3 times 16 minus 5/3. So that's going to be 2/3 times 16 minus 5/3. So that's going to be 9. So A16 is equal to 9. And then S16 is going to be equal to 16 over 2 times A1, which is -1, plus AN, which is going to be 9. So that's going to be 16 over 2 is 8. -1 plus 9 is 8. So that means S16 is going to be equal to 64. Clearing annotations. Problems 17 through 20 express each repeating decimal as a fraction in lowest terms. All right. Express each repeating decimal as a fraction in the lowest terms. So here we can say this is A over 1 minus R because delta R is, because if you think about it, this is what this is when R is less than 1, okay? So you could say that A1 is 7/10. And R is equal to 1/10. Because you multiply by 1/10 each time. So R is equal to 1/10. That being said, A1 is equal to 7/10. R is equal to 1/10. So when to find an infinite geometric series, this is an infinite because this goes on forever. Geometric series we have an infinite geometric series. And the deal with our infinite geometric series is that, and this is only when R, or the absolute value of R is less than 1, which in case it is, because the absolute value of 1/10 is less than 1, then S, the value of the series, is going to be equal to A1 over 1 minus R. So this would be equal to 0.7, 7/10 is 0.7 over 1 minus R, which is 0.1, which is equal to 0.7 over 1 minus 0.1 is 0.9. So that's going to be equal to 7/9. So this series added up infinitely is become 7/9. For 18 we'll have the same standard. A1 over 1 minus r. We just need to find out what the common change is. So this is going to be 43 over 100. That is 0.43. We are multiplying, we have a 1 in the numerator, and you're multiplying by 100 in the denominator. So 43 over 1 minus r is times 1 over 100, or times 0.01 times 1/100th times 1 minus 0.01. And so 43 over, that's going to be equal to 0.43 over 0.99. So this series added infinitely is going to equal 43/99. 0.27, continuing, you will have once again, if you want to draw this out, this would be 27 over 100. Plus 27 over 10,000. And we continue on forever. That's what it means when you have 0.272727. 27 100ths plus 27 10,000ths. That's a, because you have a 22 in the thousandths place and the 7 in the 10,000ths place. So that's going to be 0.27 over 1 minus 0.01, which is equal to 0.27 over 0.99. So the series is going to equal 27/99. Here, you have A1 is 0.345. Instead of having 0.01, now think about it. You have 1 minus point, because you have 3 terms now they're repeating, 0.001. So that's going to become 0.345 over 1 minus 0.001, 0.999. So this becomes 345,999. But 345 divided by 999 simplify to 115 over 333. So this series, infinite series, is going to, when you add it up infinitely, will become 115 333thirds. So that's the series for 20. Alright, so that was 17, 18, 19, 20. 21, when you find the sum of an infinite geometric series, if possible. If not possible, explain why. For 20, you are multiplying each term by 1/4. So this is possible. And the reason why it's possible is because the absolute value of r is less than 1/4. Or sorry, is less than 1. So we can use the formula for an infinite geometric series, a1 over 1 minus r. And this is going to be equal to a1 over 1 minus r. This is going to be equal to a1 is 3 over 1 minus r, which is going to be 1 minus 1/4. So that's going to be 1 minus 1/4. So that's going to be over 3/4. 3 divided by 3/4. So 3 over 1 divided by 3 over 4 is equal to 12/3, which is going to be equal to 4. So that's 21. 22, you're multiplying each term by negative 1/4. So here r is equal to negative 1/4. Once again, the absolute value of r is still less than 1, so this is definitely still possible. So a1 over 1 minus r, that's going to be a1 is 2 over 1 minus r. That's going to be 1 minus negative 1/4. So that's going to be equal to 2 divided by 5/4, which is equal to 2 times 4/5. That's going to be 8/5. This geometric series will converge to, the series will, when added infinitely, be equal to 8/5. Here, each term you're multiplying by 4/3. So you multiply by 4/3. And the problem is the absolute value of 4/3, because that's equal to r, is greater than 1. And because it's greater than 1, the series diverges. So therefore, the series diverges to infinity. All right, for 24, we have 2, negative 4/3, 8/9, negative 16/27. And in this case, you'll have 2. You're multiplying by negative 4/3 divided by 2. Negative 4/3 divided by 2. So our value R is negative 2/3. We can do the same thing. 8/9 divided by negative 4/3. So our value is negative 2/3. So R is equal to negative 2/3. Because R is equal to negative 2/3, that means that R is less than 1, so this is still possible. That being said, we have A1 over 1 minus R. So we have 2 over 1 minus negative 2/3. So that's 1 plus 2 over, we have 2 divided by 1 minus negative 2/3. That's going to be 1 plus 2/3. So 3/3 plus 2/3. So that's 2 over 5/3. 2 divided by 5/3 is the same thing as 2 times 3/5. So that will be 6/5. So the series will converge to 6/5. Clearing annotations. We'll have 25, 26, 27, 28, and 29. You are offered your dream job with an annual salary of $35,000 to start, with an expected annual increase of 5%. Find your salary at the start of your 5th year. All right. So your salary is $35,000. So your salary is going to be equal to 35,000 times 1.05 to the n minus 1 power. So breaking down, and this is just your geometric sequence. AN is equal to A1 times R to the n minus 1 power. Remember, 35 is A1, 1.05 is R. To find our salary, at the start of the 5th year, that means that N is going to be equal to 5. So the 5th year, so our 5th year would be equal to 35,000 times 1.05 to the 4th power. $35,000 times 1.05 to the 4th power. 42,542.71. 42,542.71. 42,542.71. So $42,542 and 72 cents, because you're going to round up. Sorry. So $42,542 and 72 cents. That is going to be your answer. Caliber 1 Construction purchases a new service vehicle for $25,000. Each year, it will depreciate the value of the vehicle for tax purposes by 12%. what will be the value of the vehicle after 5 years? So what we can do here is you have the value will be, think about it, 25,000 times, if it's decreasing by 12%, you could say you're multiplying it by 0.88. So 1 minus 0.12 to the t after 5 years, so raised to the t power, okay? So 5 years, the vehicle after 5 years, so after 5 years, t is equal to 5. So 5 years, that'll be equal to 25,000 times 0.88 to the 5th power. So you can plug in with the calculator 25,000 times 0.88 to the 5th power, and that will be equal to 13193.29. 13193.29 is equal to 13193.29. And actually, once again, when we look at the calculator, yeah, that rounds up. So 13193.30. Let's round up. $131.30. 27. In the figure shown at the right, what fraction of the square is eventually shaded if the indicated shading process continues indefinitely? So here, hopefully we can see that it's 1/4 of the total box, and then 1/4 of 1/4, then 1/4 of 1/4 of 1/4, then 1/4 of 1/4, 1/4, and it continues indefinitely forever. So it's just trying to show a pattern here. So for the first term, you have 1/4 of the box shaded, and then that second square, that means an additional 1/4 of 1/4, which is 1/16 of the total thing is shaded. And then for the third term, that's 1/4 of 1/4 of 1/4. So 4 times 4 is 16 times 4 is 64. So that's 1 over 64. And hopefully you see a pattern here, because this is going to go on indefinitely. So this pattern is going to go on forever. Which is 1 over 1/4 times 1/4 times 1/4. So each time think about it, you're multiplying by 1/4. Multiplying by 1/4 each time. That's our common ratio. So in this case, this is an infinite geometric sequence, and with an infinite geometric sequence, IGS. So infinite geometric sequence, 1/4 over 1 minus 1/4. A1 over 1 minus R. 1 minus 1/4. A1 equals 1/4. 1/4 over 1 minus 1/4, that's going to be 1/4 over 1 minus 1/4, that's going to be 3/4. One-fourth over 1, so 1/4 divided by 3/4, will be 1/4 times 4/3, which will be 4/12. So that's going to be 4/12, so that's going to simplify to 1/3. So 1/4 divided by 3/4 is going to be 1/4 times 4/3, which is going to be 4/12, which will simplify into 1/3. That's so 1/3 of this will be shaded. A family-owned screen printing company sells T-shirts and earns a $24,000 profit during its first year. The owner set a goal of increasing profits by $5,000 each year for the next 4 years. Assuming that the goal is met, what is the total profit earned during the first 5 years of business? So this is going to be a infinite sequence where n equals 1 all the way to infinity. 1/4 times 1/4 to the n minus 1. Oh, sorry, that was my work for last problem. Sorry. So for 28. Earns 24,000 profits during his first year. We need to increase profits by $5,000 each year, so think arithmetic, we're adding here for the next 4 years. Assuming this goal is met, what is the total profit earned during the first 5 years of business? Well, we're going to have a value of $170,000. How are we going to get there? Well, Sn S5 is going to be equal to 5/2 times A1 plus A5. Because we're looking at 5 years of business. A1 is 24,000. AN is equal to D. Sorry, D is 5,000 because we're supposed to, our projection, so we increase by $5,000 a year. D is 5,000. So AN is equal to DN plus A1 minus D. So AN is equal to 5,000 plus A1, which is 24,000, minus 5,000, plus minus D, so plus 24,000 minus 5,000, so that's going to be 19,000. 24,000 minus 5,000 is 19,000. So 5,000 plus 19,000. So that means AN is 5,000 plus 19,000, which means A5 is 5,000 N plus 19,000. So A5 is going to be 5,000 times 5, because N is 5 here, so that's going to be 25,000 plus 19,000. So here, S5 would be 5/2 times A1 would be 24,000. And A5 would be 25,000 plus 19,000. So 25,000 plus 19,000 is going to be 26,000. Sorry, 35,000. 44,000. So that will be 5/2 times 25,123 plus 44,000. And that, sorry, and that, oh, my fault. Sorry, I need to do 24,000 plus 25,000 plus, yes, that's going to be plus 44,000 times 2.5 is going to be $170,000. That's going to be equal to $170,000. You can also, if you want to, this would be much quicker, do 24 first year plus 29 second year plus 34 third year plus 39 fourth year plus 44 fifth year, and it's going to give you 170 at 1,000 for 170,000. So you don't always have to use the formula, but if this was a million years of business, then you wouldn't be able to just add it out. A tree farm is harvesting trees to be used in making pulp for paper manufacturing. They are required to stack the trimmed logs in the configuration shown on the right. How many logs are in each pile? So this is going to be each row is the next row plus 6. All right. So you have 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows, okay? So you need to find 10 rows, so adding up all 10 rows, S10 is equal to 10 over 2 times A1 plus AN. So there are 7 in the first row and 16 in the last row. So you can do 5 times 7 plus 16, that's going to be 4 is 23. 5 times 23. Or you can even, you don't have to do that. You can do 5 times 7 plus 16. Don't even have to do the math yourself if you don't want to. So that should give you 115 logs. Once again, this is also fast enough that you could just add it out with your calculator pretty quickly. But anyways, that's the entire homework. I was slow and methodical. Play some times 2 speed if you want, and that's the video.